All right, in this video, I want to integrate these two expressions over here. So I'm going to start with the first one. Substitution won't work in these questions, so we have to integrate by parts. So the equation for integral by parts is the integral of fg prime is equal to fg minus integral of f prime g. In this question here, I'll pick f as x, and I'll pick g prime as e to the 3x plus 4. I need to derive the first one. I need to integrate the second one. So f prime equals 1 and g equals, this you can do with substitution, but it's pretty easy to tell the solution instantly. For an equation, it's just the same thing divided by the derivation of the exponent, and that's assuming that it's just a linear equation in the exponent. You can't really do this for all types of e functions, only ones with a linear exponent. Now I'll sub it into this equation here. F times g is just x times e to the 3x plus 4 over 3 minus integral of f prime times g is just 1 times this, which is basically e to the 3x plus 4 divided by 3 dx. Now I need to integrate this over here, which again is pretty simple. I'll just write this term the same. I'll put the denominator over everything. I'm going to integrate this. The integral of an e function, again, this is assuming it's only a linear function in the top. If there was no linear function, you'd have to do substitution and parts. If it's a linear function, I know I can just divide by the derivation of the exponent again, which is again 3. So 3 times 3 will just be 9. And I'll just have plus c for my constant. So that first question there, pretty simple. It's just your regular integration by parts. Let's go to the second question over here. This one is slightly harder. Okay, if you try to do substitution here, maybe you might pick u as x cubed, and then if we derive this du over dx, that's 3x squared. And if I isolate my dx, I'm going to cross multiply. So du over 3x squared equals dx. Now, if I replace this dx with du over 3x squared, it's not really going to cancel with this x squared. If I turn this x cubed into a u, everything's going to get extremely complicated. So substitution doesn't work here in terms of just regular substitution to try and solve. Now we can do parts on this. So if I do parts, for example, if I pick f prime as x cubed, f as x cubed and g prime as e to the x squared, this is easy to derive, but this is very hard to integrate. So you don't want to do this over here. And if I even flip these around, the integration in my parts will get extremely complicated as well. So you don't want to do parts instantly on this. If substitution doesn't work and parts doesn't work, we have to do a combination of both. What you actually have to do in this question is you have to make u equal to x squared. So du over dx equals 2x. And then if I isolate dx, du over 2x equals dx. I just cross multiplied those. So now I'll replace, in this equation, I'll write the x cubed the same. I'll replace the x squared with my u. So I have e to the u. And I'll replace the dx with du over 2x. So du over 2x. Next, I'll just cancel x and the cube to make it a square. So now I have integral x squared e to the u du. I know that x squared is just, I also have divided by 2, so I'm going to write it like that for now. So next step, I'm going to factor out this 2 because we want to factor out constants so that it's easier to integrate. And then x squared can just be replaced with u. So u e to the u du. Now that I have it in this form, I can do parts over here because it's going to be much easier to do parts on this equation. So fg prime equals fg minus integral f prime g. So I'm going to pick my f as u. I'm going to pick my g prime as e to the u. So f prime is just 1, and g is just the integral of this, which is e to the u. So now I'll put in my equation. So f times g is u e to the u minus integral of f prime times g is 1 times e to the u, which is just e to the u. And I have a du over here. I just have to integrate this, which is pretty simple now. Integral of e to the u is just e to the u plus c. Also, don't forget we have our 1 over 2 outside the integral. Now I'm just replacing the u's with x square. So I have 1 over 2 x square e to the x square minus e to the x square plus c. And then I'm finally just going to multiply this 1 over 2 into this bracket. So I have x square e to the x square over 2 minus e to the x square divided by 2 plus c, and that is my final answer for this one.